Okay, guys, welcome back to yet another episode of DSA Python series. And today we will talk about uh, linked list we've seen last yesterday. Okay. Just give me a second. So this was what we were seeing. Okay. Now, so let me start X Kelly draw. Okay. Doubly linked list. Okay. So what do you mean by doubly linked list? What do you mean by doubly linked list? Right? List. Okay. How do you define or how can you explain what a doubly linked list is? Let me just copy this. This. Next. Say doubly linked list. Okay. Live now. Just post it. Just post it. Okay, so now what do you mean by doubly linked list? Okay, so let's say this is my so doubly linked list means that there can be other list. Okay, and what I can do is in a singly linked list we used to traverse on the one side only, right? Maybe on the right hand side, right? We could do that traversal towards one way. Okay, now in doubly linked list we can also do traversal on the opposite side, right? We can also do like this. Okay, you can do the traversal like this, right? Now in singly linked list we had a value, right? We had a val and we had a address or the next, right? So this next was the address of this node, next node, right? In doubly linked list we now have one more address where you save the address of the previous node. Okay, save the address of the previous node. Okay, so this is called as doubly linked list, and let's say here it is some, let's say 718.912. It means that this is 912 and this is 718, right? So this is corresponding to this node and this address is corresponding to this node. Okay, so we can also search the definition. Okay. Define doubly linked list. Okay. What it gives, doubly linked list is a linear data structure where each node contains three parts, right? So this is data, this is next, and this is previous, as I already told you. Each node stores data, which is the actual value, next pointer, which points to the next node, and there will be a previous pointer which points to the previous node, right? So this is the previous node. Okay, so we have this example. Let's say we have null, um, then we have 10, then we have doubly linked list, then 20, then 30, then null, right? So this is the example of a you can just put this here also, right? this is the example of the doubly linked list, right? Now, so how do we define so what we will do is we have this 10 dot next will be 20, right? But 20 dot previous also we have to define, because we have to satisfy this back. So 20 dot previous is will correspond to 10, and 20 dot next will correspond to 30, and 30 dot previous will correspond to 20, right? Like this we will have to do. Okay. So can we have insertion at some position? Okay. So we have to design a linked list. So we have to insert in a doubly linked list, right? So this is the next question. Okay. So this class node is given. Okay, this is the class node, and we have this class solution wherein we have to define insert at position, which will take head p and x. Now, what are p and x? Given the head of doubly linked list, position p is given, and integer is x is given. Insert a new node with value x. So this value wala node we have to insert at a position p, right? So where do we have to insert? We have to insert a new node with value x at the position just after pth node. So just after pth node, we have to insert this, okay, in the doubly linked list and return the head of module. So we have to return. So output will be like this, right? So this is 2, 4, and 5. Okay. So p is equal to 2. It means that uh, 0, 1, 2, right? So just after the pth node, okay, just after the pth node. To a second node means 0, 1, 2, and after this we have to put the x is equal to 6, right? This we have to do. Okay. So it means that I have to assume one counter which will take the value from 0, okay, and that 0 value will be head wala value, right? Okay, so let us do this question first. Doubly linked list from an array. So we have been given an array. Goal is to create a doubly linked list where the array is represented as node. Okay, the node must be linked in the same sequence as the array, maintaining both forward, next, and backward previous connection. Return the head of the. Okay, so this class node we have defined, right? It's given that we have to define init. This is a constructor. Okay, dot data is equal to data, and we have to define the next, the previous, which will, it means that we node, right, which will contain, but the previous and the next and the previous element, or you would say node, we don't know. Okay, this is why these values are none. So it means that if I consider this, okay, so if this is my, let's say if this is my node, okay, let's say if okay, so let's say this is so this is val, okay, and this is my value, and this side it is empty, right? So this is none, right, and this is also none. Okay, okay, so both side it is none, right, and in the center it is value. Okay, so uh, so here the same is defined, right? We have this self dot next equals none and self dot previous equals none, right? Then we have class solution, so this is another class, and inside this we are defining create double linked list, right? It means that we have to create double linked list from the array of integers. Okay, so array of integers is given. What we have to do, uh, we have to traverse the for loop, right? How can we do that? Okay, so I need to traverse. We are traversing the array through for loop. Okay, and just say n is equal to length of ARR. Okay, and can I prepare all the node first? We can say node of I. Okay, so let me try to if I so new node is equal to node of I, okay, and if new node is not equal to none, okay, it means that I have to so let's consider there is a first of all there is no node, okay, it means that so self dot head is equal to none. Starting, we don't have anything, we don't have any node, okay, so self dot head is equal to none. Self dot head is equal to none. First we have to see this, right, okay. So but here I have defined an constructor self, and here I have to do this self dot head equal to none. Okay. Then I'll create this. Okay. Create DLL. Now from head, um, now can I have a new node but that should be in the for loop. Okay, so new node is equal to node of I. Okay, so let's say I is equal to 0. So input 1 2 3 4, so node of 1. Okay, now new node is equal to node of 1, right? Now what I have to do, node 1 के लिए I have to define one next and I have to define the other as null, right? So node but for node I have to, new node is node of I. Okay, so I have to take node of ARR of 0 as this. So I have to assign my node of ARR of 0 as my head. Yes. Okay. So I have to assign head is equal to node of ARR of 0. Okay. And after this, what I'll do is, after this, what I should do is, we can start a for loop from 1, right? Node of ARR 0. So I'll just assign temp is equal to my head. Okay. And then I'll start this for loop from 1 to n. Okay. Now my temp is head. So so I want temp dot next. So temp is equal to temp dot next. So at first position, my new node will be node of ARR of I. So node is equal to node of ARR of I. Okay. ARR of I. So new node will be this. Okay. And my next node will be, so new node will be this. So my node of ARR I dot prev is equal to temp. Okay, or you can say head, and this is previous wala. Next wala will be uh, node of ARR of I dot next is equal to node I plus 1. Can I write this? But I have to take in temp wale terms now. So what is my new node? New node is my this node of ARR of I. So I have to do temp dot next is equal to, okay, my temp is head. So temp dot next is equal to new node, right? New node we have assumed node of ARR of I, and temp is my head. Yes. Okay. And then so we have connected current node to the new node. Now we have to connect the previous node back to current node, right? So new node dot prev. Okay. New node dot prev is equal to my temp, right? After this, temp is equal to new node. After that, temp becomes new node. And in the end, I'll just return head. But here I have to put that condition also, no? If it is none. So n is equal to 0, then return none. Can I compile and run it? Okay, my output has come. Compilation completed. Let's submit it. Okay, so this question is solved. So what I've done is I have just taken a head which is none, because right now I have just an array of numbers and I don't have any kind of linked list or doubly linked list, so everything is empty. That is why I have taken some head as none. Okay, self dot head is equal to none. Now I'll create a function create DLL, right, which will take to which will take input as array, this array. Okay, this will take input. Okay, so let me just start from here. We can discuss this later. Now I have assumed my head as none as of now. Means I have created a head, but it is empty. Okay. Now what I'll do is I'll give that head a value. I'll give that head a value. So here I have given head is equal to node of ARR of 0, because I want the 0th position should assume the value head, right? It should assume the value. So once I have got my head, I can play with temp, because I have to traverse the whole loop. Why I need to traverse? Because my question is saying I have to create, my goal is to create a doubly linked list where each element of the array is represented as node. Okay, so I have been given an array and I have to, using this the values of array, I have to create a doubly linked list, right, one by one. Okay, so as of now I don't have anything. I just have my head. I have made a head. Okay, this will take ARR of 0 as the value, so this will be the head. Okay, and let us assume the value temp as head. Now we can start a for loop. Okay, so I will start for loop from 1 to n, because I have already assumed the value ARR of 0 to head. I have already given this value, so leaving the head I'll start from first element. Okay, so what I've done is new node is equal to, I have considered whatever will be my new node. Okay, so let's try to understand this. Okay, so this is, so this is my head, this is my head. Okay, now what I have assumed is, after this, new node is equal to node of ARR of I. Or let's say this ARR of I is, this also we take here, this is my ARR of I. Now what I'll do is I have assumed this, I have assumed this as the 0th position. Okay, or head, and I have assumed head as ARR of 0, right? So this value will be 1. Okay, this value is assumed. Now in the for loop I have taken this new node is equal to node of ARR of. Okay, so here new node is equal to node of ARR of I. What is I? I is starting from 1 to n. Okay. So I is starting from 1 to n. Okay. So at I is equal to 1, my new node becomes node of ARR of 1, which is this. So this will be node of 2. Okay. So this is my node 2. Okay. So this will create a linked list which will have this as the node. Now let's go to the now I am taking temp dot next is equal to new node. Okay, so my initial value temp is equal to head, right? So this I'll also write is this temp is equal to head, and here I am doing temp dot next means this is temp, this is my temp. Okay, this is my temp and temp dot next. Okay, temp dot next is equal to what I'm doing, new node, right? So that this link is established. Okay, so here temp dot next I'm doing is new node, right? So temp dot next is new node means node of 2 means this one. So I have established a address, or you can say a link in the forward direction. Now I want this backward direction also. मतलब 2 से 8 के लिए भी I need to have a link. So what is my 2? So this is my node of 2. I'll just write it. Node of 2. Okay. ये left वाला बन गया. Then right वाला how do I do? मुझे node of 2 prev, right? So मुझे node of 2 जो prev है उसको मुझे temp लिखना पड़ेगा, right? So जो भी node of 2 means my new node जो था उसका prev will be my temp. Okay, it means that मैंने यहाँ लिखा node of 2 or new node. Okay, because my node of 2 is my new node. So new node dot prev means previous. This will be my temp, right? This will be my temp. Okay, so what I've done is I have established this relationship also, right? I have established this relationship. Now then my temp will be equal to my new node. Okay, once I have established the relationship, what I'll do, I'll shift my temp. So the temp is just a temporary number, right? Once I have pushed once I have established this link, what I'll do, I'll just shift my temp to second node. It means that on the new node, right? So now the value of temp, the value of temp will be equal to my new node. Okay, it means that I have shifted. With this I have done linking. With these two commands I have done linking. After this linking I have to shift also. No, I have to shift this temp, because temp is just a temporary number which I have assumed. Temp को मैं move करूंगा तभी I can play on temp, right? Because this also, when 2 is there, then again मुझे temp का next करना पड़ेगा so that I can point to this, right? This temp का next अगले iteration में again I have to do. So this will become node of 3. Then इधर new node जो है ये वाला न्यू नोड तो एवरी टाइम आई एम अज्यूमिंग ना नोड ऑफ ARR of I, तो न्यू नोड तो हर बार चेंज हो रहा है. न्यू नोड इज फर्स्ट इट इज 2, then it is becoming 3, then it will become 4. So I don't have to worry about my new node कि new node मेरा चेंज हो रहा है कि नहीं. new node भी मुझे शिफ्ट करना है ना, that is what. So new node is already getting shifted. All I want to do is मुझे temp को shift करना है to every node. Okay, after every iteration, after every this linking is done, okay, I have to shift this my new node and temp. Okay, both thing I have to do. So this is how this code works. Okay, so and in the end I will return the head. Okay, the only thing we have to take care that let us not get confused with should I put head or should I put temp. Head is the fixed thing. Head is already fixed. Okay, we don't have to juggle head inside, right? We don't have to put head inside the uh, for loop. Okay, so I will play with temp. I will play with temp and my new node. That's it. I will just do temp dot next pehle, then I'll do new node dot prev equals temp, then I'll shift. So this is shifting of temp. Okay, yes. Assigning address to previous node, right? And this is assigning address to next node, right? This is how it will be taken care. And this is the node which you have to put every time, right? In place of node in place of new node you cannot use this node ARR of I here. Why? Because every time it will change, no? So if you have to put the variable constant, you have to assign the value, and that value you have to that value should be fixed, okay, for a particular iteration. That is why. Okay. Okay. And what about this if n equals 0? So for example, the array which we want to create is itself does not exist, then there is nothing we can think of creating any kind of doubly linked list. So it will also not be created. Why? Because there is no array. Okay, that is why if my length of array itself is 0, it will not exist. When array does not exist, then I don't have to create any kind of doubly linked list, right? So that is this code. So this is a very logical question. This question will work, or you will understand this question if and only if you have studied singly linked list. Your concepts are very clear about singly linked list, then only you will be able to do. Okay. Okay, insert it. Let's do this. Did I submit it? Okay. So given the head of a doubly linked list, position P and an integer x, insert a new node with value x at the position just after pth node, okay, in the doubly linked list, and return the head of the modified list. Okay. So we have this head given. We have a doubly linked list at position. Okay, so first of all, we will define init function. Should we define? No, we don't require, because head is already given the head of the linked list. So we don't require to do that constructor thing, and self dot head is equal to none. We don't have to do that. Okay. Position just after p node 0 indexing in the doubly linked list. Okay, so we actually have to traverse through the doubly linked list. So to insert at any position, can we put a number, a count, which will be equal to 0 in the beginning? and if the value of count reaches the x, so if value of count so when count becomes equal to 6, when count becomes equal to 6, then I have to put that next uh, temp is equal to head y temp dot next is not none. No, it's not about none. Y temp dot next. That's it. Okay. Y temp dot next. Simply say temp is equal to temp dot next count plus equals 1. Okay, but I have to put a condition when my value, or I would say the position p is given, is X in the position. Mhm. So we have been given the head of doubly linked list. We have a position P. What I'll do is I just have to traverse through the loop. Yes. But how do I check whether that node, this pth node, has come? That I'll check through count. Okay, so whatever is the position P, that will be my count only. So let's say my temp I have taken as head. Okay, and count I have already taken 0. So as long as my position, okay, so while temp, and I'll just put and position, that is P. Okay, temp, and my count is less than P now. If my count is less than P, so every time I'm increasing this count value, okay, it will check every time what is the value of count. Okay, and null head. Temp is equal to temp dot next. This will keep going. Let me just assume a new node. Okay, because that new node I have to insert, right? So I will just say new node dot next is equal to 10 dot next. न्यू नोड का प्रीवियस इज इक्वल टू माई टेम्प, राइट। इज इक्वल टू टेम्प। Okay. So if current dot next, so if temp dot next, okay, so next, and my temp dot next is equal to new node. New node is not defined. So new node will be whatever is the node of val, right? New node is equal to node x. Two, four, five, six. Okay, so this is working now. What is the problem? We have to take the edge cases also. If head is equal to none, then return none. But head is already given, no? I cannot take head as none when head is already given in the question. So what I can do is, if my position P is equals 0, P minus 1. 2, 4, 5, 6, 2, 4, 5, 7. It is correct, coming correct. Two, 4, 5, 6, 7. It is coming correct, man. It's look like you are on the right track with your implementation, but there are a couple of things to consider regarding the insertion logic. Boundary condition. Make sure to handle a case where P is equal to size of the list. In this case, you would be inserting the new node at the end of the list. Okay. Deleting previous node. When you insert the new node, ensure that you are correctly linking the new node to the node that comes before it. Okay. So if position equals P equals 0, I'll just insert at head. Okay, so if P is equal to 0, then I will just call that function. Okay, call the function which will insert the element, or I would say node, at head. Okay, so this question is incomplete without doing this head wala question. Okay, so tomorrow we will do this head wala question, then we will come back to this question. Okay, so that we get a clarity, we get a clear idea of what we are doing, and when we are calling this function, what is happening, right? So till then, guys, just okay. So once we get this function, okay, that we will do tomorrow, we will be able to complete this question. So let's continue this question tomorrow. Okay. Um, so I would request you to come online at 11 between 11 to 11:30 p.m. Right? Let's continue tomorrow. So here is the end of the today's stream. Okay, I'll see you tomorrow, guys. Bye bye and take care.